Hi students. The last thing we're going to learn in our solving equations units is what happens when we solve equations that end in special cases. So sometimes you'll solve an equation and something weird might happen. So we're going to talk about what weird things could happen and what they actually mean for the solution. So there's two scenarios that you may encounter. So I'm just going to divide my page up. Okay, let's suppose you have an equation, something equals something, right? And you draw your line and you solve, and then you get to the bottom, and for some reason your x's or your variable terms completely disappear. Maybe they cancel out to zero somehow. And then maybe you end up with something that looks like this. Basically, you end up with an equal sign and a number on each side, but those numbers aren't equal, right? If it is not equal, then this means you have no solution. And what that means is there is no value of the variable that will make the left side equal the right side. It's actually not equal. Nothing will make it equal. So if you end up with a number equals another number, and they are truly not equal, that's what that line through the equal sign means, then you can write no solution as your answer. Alright, let's look at the other scenario you might encounter. And this one could look a couple different ways. So let's say you have another equation, you solve it, and then at the bottom, maybe you get something like this. You might get x equals x. X. Or maybe you get 0 equals 0. Or maybe you get 2 equals 2. So you don't really get a variable equals a number. You actually get two things that are exactly the same on either side of the equal sign. This is called an identity. What this means is that there are infinitely many solutions. Infinitely many solutions. And so what that means is any number that I put in for my x or my variable will always make the left and right sides equal. Any number I choose. There are an infinite number of numbers that I could plug in that will work. So basically all the numbers are a solution. Another way you might see this written as is all real numbers. Sometimes they'll say that. So if asked what's the solution, you can say all real numbers. You can say infinitely many solutions. You can even abbreviate infinitely many solutions with IMS, infinitely many solutions. So let's take a look at one of each example so you can see what this is going to look like. All right, let's try this example. We're going to solve for x using our 6 steps that we're used to. First one says we're going to distribute if we have parentheses, which we do. The number outside of our parentheses is this -2. So we're going to multiply that by both the x and the 7. Let's see what happens. We're going to bring down that 2x. Now let's multiply. -2 times x is -2x. -2 times 7 is -14 equals 20. Alright, step 2 says clean up each side. On the left side, I can combine my 2x with my -2x. Now what happens when I combine those? They actually make 0. 0x. If I have a coefficient of 0, that term is really not even there. I don't really even have anything there. So I don't have to write anything. So I'm going to bring down my -14 equals 20. So back to that 2x minus 2x, those actually cancel out to 0, right? So let's look at what my solution is. So I get -14 equals 20. Well, first of all, I have no variable anymore, which is always what's going to happen when you have this scenario. And I've got two numbers that do not equal each other. So if I end up like this, that means there is no solution. There is no value for my variable that will make the left and right sides equal. No solution. All right, here's our last example. So we're going to draw our line. We're going to use our 6 steps and see what happens. Step 1 says distribute when you have parentheses, which we do. The number in front is a positive 2. So we're going to multiply that by x and times negative 2. All right, let's bring down everything else. So we're going to bring down the 8. Now let's distribute. 2 times x is just positive 2x. 2 times negative 2 is negative 4, and that equals 2x plus 4 on the right. All right, step 2 says clean up each side, combine any like terms. On the left, I can combine my 8 and my negative 4, which makes positive 4. Oops. Bring down that 2x equals 2x plus 4. Now some of you may notice something now, maybe you don't. Let's keep going through the steps. Step 3 is move all your variable terms to one side. Let's go ahead and move all of our x's to the left. So that 2x on the right, I'm going to move to the left by subtracting 2x on both sides. When I subtract 2x from 2x, I get 0. And when I subtract 2x from 2x, I also get 0. Uh-oh. Something weird's happening. So my variables are completely gone. Sometimes that'll happen with this scenario, sometimes it won't. Let's bring down what's left. 4 equals 4. So this is kind of like the other example, except in this scenario, my variables are gone and I have 2 numbers at the end that equal each other, but they're exactly the same number. So they truly do equal. So what this means is I have infinitely many solutions, which means any number I put back in that original equation for x will always make the left and right sides true. So these are some weird things that can happen. It doesn't necessarily mean that you did anything wrong. It just means this is a special case. When we get a little bit later into the year, you'll find out, well, what do these mean? What do these mean when I'm graphing? But for right now, as you're solving, if you get any of these 2 cases, know what they mean. All right, that's it. Nice and short and sweet. See you in class.